Everyone assumes the battery war is still competitive. It isn't. And the number that proves it came out of a single press event in Beijing in April 2026, 350 watt-hours per kilogram. That is what CATL unveiled at its Super Technology Day. Not in a lab, not in a prototype, in a mass-produced cell, inside a pack, light enough to fit under a standard passenger sedan. And that sedan, the company claims, will travel 1,500 kilometers on a single charge. That is roughly the distance from London to Warsaw without stopping once. That number matters. But here is the twist. The battery itself is almost the least alarming part of the story. There are really three problems converging at once, and Western engineers can see all three. By the time you understand all of them, you will realize why the word panic in this video's title is not an exaggeration, it is an understatement. Let's start with what that battery actually is. CATL called it the Qilin condensed battery. They say it borrows technology from electric aviation, the kind of engineering you normally see on aircraft, not family cars. The titanium alloy casing is 60% thinner and 30% lighter than conventional battery housings, while being 3 times stronger. Inside, a condensed electrolyte replaces the liquid electrolyte that every lithium-ion battery in your phone, your laptop, and every Western EV on the road right now still uses. The result is 350 watt-hours per kilogram at cell level and 760 watt-hours per liter of volume. To give you a frame of reference, the battery Tesla uses in the Model Y sits at roughly 160 watt-hours per kilogram at the pack level. CATL just more than doubled that at mass production scale. And CATL didn't just bring one battery to that April event, they brought 6. The third-generation Qilin for premium vehicles at 280 watt-hours per kilogram, targeting 1,000 kilometers of range. A super-fast charging version, the Shensing, that goes from 10% to 80% charge in 3 minutes and 44 seconds. You read that right. Less time than it takes to make a coffee. They also unveiled a sodium-ion battery hitting gigawatt-hour scale production. No lithium required. And a sodium-ion pack ready for full mass production by the end of 2026. 6 platforms. 5 distinct chemistries. 1 company, 1 day. Stay for that, because the second problem is where it gets heavier. The battery is the product, but the supply chain is the weapon. This is the part almost nobody talks about, even among people who follow this industry closely. China does not just build the best batteries. China controls the materials that every battery Chinese, American, European, Japanese needs to exist. Not most of the materials. Essentially all of them. China accounts for over 80% of the world's lithium-ion battery production output, according to IEA data for 2025. The 6 largest global battery cell suppliers are all Chinese: CATL, Lithium, Eve Energy, BYD, Calb, and Rep Batero. 9 out of 10 names on that list. The one outsider barely registers. But go one level deeper, to the raw ingredients, and the picture gets starker. China processes over 90% of the world's graphite. In the refining of rare earth metals, the elements that go into the motors, the magnets, the precision components of every advanced battery system, China accounts for 92% of global processing capacity as of late 2025. Not a majority, not dominance, near total control. For 19 out of 20 important strategic minerals, China is the leading refiner, with an average market share of 70% across all of them. And here is what that actually means in practice. A battery built in a factory in Ohio or Bavaria starts its life in a Chinese refinery. The lithium, the graphite, the cathode precursors, they go through China first. One expert put it plainly, even if you build the cell outside China, the raw materials for that are being processed and refined in China first. It's the same starting point everywhere. That dependency has a hard edge now, because Beijing chose to turn it into a lever. In October 2025, China announced sweeping new export controls covering battery cells and packs for high-performance applications, cathode precursors, anode materials, lithium iron phosphate cathode materials, and critically, the manufacturing equipment and technologies used to produce them. The controls came into full effect in November. They also added a clause that extended the restrictions to products made outside China using Chinese-sourced materials or Chinese manufacturing processes. That is not just restricting what leaves China. That is reaching into factories in Germany and South Korea and the United States and saying, if Chinese origin material touched your process, you need a license from Beijing. And there is a specific threshold buried in those export rules that should alarm every EV engineer in the West. China introduced permit requirements for high-performance lithium-ion batteries with a gravimetric energy density above 300 watt-hours per kilogram. Think about that number. CATL just publicly demonstrated 350 watt-hours per kilogram at mass production scale, which means China has effectively built a wall around the technology tier it is about to enter and erected that wall before Western manufacturers have even reached the base of it. And it gets crazier. Because the third problem is the one that makes the other two feel permanent. The gap is not just a technology gap, it is a scale gap. And scale in manufacturing is almost impossible to close quickly. In December 2025, China installed 65 gigawatt-hours of large-scale battery storage in a single month. The United States installed 58 gigawatt-hours in the entire year. China did in 30 days what America did in 365. That comparison comes from benchmark data, and it sits like a stone when you let it land. China already holds close to 40% of all global battery-based energy storage capacity. Its battery exports grew 51% in the first 11 months of 2025 compared to the year before. The global market for lithium-ion batteries crossed $150 billion in 2025, a 20% jump year-on-year, and Chinese producers captured the dominant share of that growth. The pricing tells the same story from a different angle. A battery built in the US or Europe costs roughly 50% more than one built in China. Not 10% more, not 20, 50. That is not a gap you close with a subsidy or a trade barrier. That is a structural cost advantage built over 15 years of coordinated investment, supply chain integration, and a domestic market large enough to absorb the early losses that learning at scale always produces. China fused industrial policy with manufacturing volume starting around 2009. The 10 cities, 1,000 vehicles program, followed by the NEV subsidies, followed by Made in China 2025. By the time the West began to respond seriously, China already held 70% of global market share. The US attempted a frenzy of policies in the 2020s, many of which have since been reversed or altered. And the next front is already being set. CATL and BYD have both announced targets for small-scale, solid-state battery production by 2027, with mainstream vehicle integration by 2030. A Chinese market research firm projects that China's solid-state battery equipment market alone could grow at a compound annual rate of 122% between now and 2030. China has also become the first country to publish a globally recognized standard defining what actually qualifies as a true all-solid-state battery, the technical definition that will govern the next generation of international regulations. More than 50 organizations, including CATL, BYD, and Tsinghua University, developed it. They wrote the rulebook before the competition had finished reading the last one. Toyota is targeting 2027 for its first solid-state mass production vehicle. Samsung SDI is on the same timeline. Mercedes-Benz has road tests running. These are serious programs from serious engineers, but they are also chasing a moving target, and the target just jumped. Here is the honest summary, because this channel doesn't do false comfort. The battery that triggered this video is genuinely extraordinary. Engineering 350 watt-hours per kilogram in a mass-produced cell is a number that, 5 years ago, most Western engineers would have placed firmly in the category of aspirational roadmap, not shipping product. The fact that CATL unveiled it alongside 5 other platforms at a single event suggests this was not a one-off achievement. It was a demonstration of depth. But the battery is almost secondary to what surrounds it. The supply chain control, the export restrictions calibrated to lock out the next tier, the production scale that no Western factory currently matches. The standard setting that shapes the rules for the next decade. These are the four walls of a structure that took 15 years to build, and that cannot be dismantled by a tariff or a press release. What can be done? The Western response is real. The U.S. doubled its battery manufacturing capacity between 2022 and 2025. Europe has factory investments coming. J.P. Morgan launched a $1.5 trillion initiative targeting critical minerals and strategic industries. Australia, Brazil, and other nations are being pulled into new supply partnerships. These are not nothing. They are the beginning of a serious industrial counter-effort. But the honest question, the one the engineers asking it already know the answer to, is whether a counter-effort that started in 2022 can close a gap that started in 2009 on a timeline that matters for the energy systems being built right now. The next chapter of this race, solid state at scale, sodium ion in the grid, condensed matter chemistry in the air, is already being written. Most of the ink is coming from one direction. If you want to track where that goes and what the rest of the world is building next, this is the place to be.